Hello, my name is Michael Galarnik. In this video, I'll go over my group's paper, How Inclusively Do Language Models Perceive Social and Moral Norms? As a word of warning, this paper contains offensive content, as language models are increasingly being prompted for subjective judgments. Understanding whose opinions models represent is important. For a bit of background, social and moral norms shaped by culture and society, are often at the core of judgments, guiding what's acceptable behavior and what's not. Descriptive cultural norms, otherwise known as rules of thumb, abbreviated as ROTs, such as it's good to work from home or it's good to be patient, inherently lack a single correct answer. These ROTs are subjective, context dependent, and often culturally influenced, making them ideal candidates for evaluating how well LLMs can approximate human perceptions. Rather than directly asking about a person's perception, Bayesian truth theorem suggests that impersonally informative questions get more honest answers. In order to assess the perception of language models on norms, we utilize the Social Chemistry 101 dataset by Forbes. It's a learn-to-reason dataset on social and moral norms annotated via Amazon Mechanical Turk. Specifically, we only use the 400 ROTs that have been labeled by 50 human annotators each. This subset is comprised of 100 ROTs from each of the following data sources. There's a subreddit r/confessions, which contains often explicit user confessions about their actions. There's also the subreddit abbreviated as AITA, where users seek moral judgments on interpersonal scenarios. Next is ROC Stories, which is a collection of everyday life stories. And finally, there's Dear Abby, which is drawn from advice columns where individuals seek moral guidance. This leads us to our research question. How inclusively do language models perceive social and moral norms across different demographic groups? This work's prompts are designed to be similar to a task posed to the human annotators in the creation of the Social Chemistry 101 dataset. We prompt what percent of people probably agree with a given ROT. In the end, we compare human and LM annotations. We not only compare all humans to language models, but also different demographic groups like gender, age, and income to language models. As far as contributions to this paper, we analyze alignment between LMs and humans on norms. We also design a new ordinal metric called absolute distance alignment, abbreviated ADAMET, to quantify alignment. We also report patterns in LM's reflections of societal norms. Our LM prompting, extraction process, and human alignment analysis is depicted in Figure 2. The LMs are tested using 3 different prompts: zero shot with option descriptions, and zero shot with option descriptions presented in a markdown table. It's important to note that we prompted 11 LMs, including Arctic, DBRX, Gemini 1.0 Pro, Gemini 1.5 Pro, various GPT and Llama 3 models, as well as Mixtral 8x22b. Now moving on to results. Using Crippendorf's alpha, we found that LMs tend to disagree among themselves less than all human annotators. Furthermore, LMs within the same family show higher levels of agreement. And finally, zero-shot table prompts tend to produce greater consensus. In this work, humans and LMs answer questions with ordinal options. The problem with using accuracy as a metric for this particular task is that it treats these options as categorical. For instance, treating both A and E as equally incorrect when the correct answer is B ignores just how far apart each is from the correct answer. Our metric, ADAMET, builds on L1 distance by selecting the most frequently chosen human option for each ROT, and then taking the absolute value of the difference between it and the LM response. How the metric works is shown on the screen. Human and LM choices are first converted to numeric and then put into the metric. This table shows the agreement in terms of average data met for the different data sources. We noticed that the prompt zero shot with option descriptions in a markdown table performed very well. We next look at data-met distributions. In general, the models are 0 or 1 option away from the human choice. We next turn to the demographics with the highest alignment with LMs. In summary, models tend to agree with each other more than humans and perceive social and moral norms like younger, healthier adults. We are also able to develop a simple ordinal metric to quantify LM human alignment. We hope you enjoyed this presentation. Thank you.